Try to recall the very first day you were alive, the faces in the room, the sounds from the hallway. You can't. This universal blank slate has a name: infantile amnesia. Almost no human being can retrieve personal memories from before the age of 3 or 4. Sigmund Freud used the term to describe this missing chapter in our personal history. For over a century, the medical explanation was simple: biological immaturity. Researchers assumed that a baby's brain, specifically the hippocampus, was just too underdeveloped to record information in a permanent way. However, this assumption is contradicted by how infants actually function. A brain that cannot record information cannot learn. Yet in those first years, a child learns to recognize parents, navigate their home, and understand language. This is because memory isn't a single system. Implicit memory allows us to retain skills like crawling or walking without conscious effort. Explicit memory is what we use to archive the specific events of our lives. In deferred imitation tasks, toddlers watched specific actions and perfectly recreated them months later, proving long-term declarative memory is active long before childhood recollections. While behavioral tests proved memories were recorded, the biological mechanism remained invisible. We couldn't see how brains stored the data. It raises an investigative question. Are the first years of our lives truly blank, or are those memories stored in a place we simply cannot find? To find the answer, science had to move past observing behavior and start looking directly at the activity of the awake infant brain. A breakthrough study led by researchers at Yale and Columbia finally bridged this gap. They developed a specialized functional MRI protocol that allowed them to scan the brains of awake babies while they were engaged with the world. During the study, 26 infants viewed a sequence of images, some new, some repeated. By tracking blood flow in real time, the team could see exactly how the brain responded to each visual encounter. The data was definitive. In 4-month-old babies, the posterior hippocampus actively lit up as it encoded new visuals. Furthermore, the intensity of this response predicted later recognition, showing their encoding process works with the same fundamental logic as an adult's. The infant brain's record button works perfectly. Infantile amnesia occurs because our adult minds can no longer navigate to the original data. One primary reason these memories become unreachable is a biological process called rapid neurogenesis. In infancy, the brain produces new neurons at its fastest lifetime rate. This explosive growth adds so many new connections to the hippocampus that the physical pathways to older memories are effectively overwritten and scrambled. A second barrier involves the acquisition of language during early cognitive development. Because infants encode their experiences without words, they save those files in a nonverbal format. As we grow, our retrieval system becomes language-based. We eventually lose the ability to search for those pre-verbal files, using our adult, word-based thinking. The massive structural remodeling of the hippocampus and the transition to a language-based operating system effectively partitions our earliest experiences away from our adult selves. Infantile amnesia is not a uniquely human trait. It is observed across many species. This allowed scientists to test whether these forgotten memories were truly gone by using animal models. In one experiment, infant mice were allowed to form a specific memory. Once reaching adulthood and unable to retrieve that memory naturally, researchers attempted a direct intervention. Using optogenetics, scientists applied targeted light to stimulate the specific neurons where the infant memory was originally stored. Upon stimulation, the adult mice instantly recalled the forgotten information. Their behavior proved that the memory had been there all along. It was simply inaccessible. The evidence suggests that our first memories are never deleted. They remain archived in the brain's tissue, even if biological pathways to reach them have failed. This leads to a common contradiction. If the archives are unreachable, why do some adults claim to have clear memories of being a toddler? Most of these cases are the result of telescoping. This is a cognitive bias where we take events that happened when we were 4 or 5 and systematically misstate them, convincing ourselves they occurred much earlier in life. We also experience source misattribution. By looking at old photographs or hearing parents repeat family stories, the brain constructs a mental image. Over time, we begin to mistake that reconstructed image for a genuine episodic memory. The boundary of infantile amnesia remains largely absolute. What we often perceive as our first memories are usually stories we have told ourselves long after the facts were recorded. Why would evolution favor a brain that makes its first years of experience unreachable? In a period of such rapid development, the mind's priority is not to keep a diary of specific events. Instead, it is tasked with extracting general rules and patterns about how the world works. By prioritizing the acquisition of language and the formation of social attachments over the storage of specific childhood details, the brain optimizes itself for survival. You may never be able to consciously visit your earliest years, but those inaccessible experiences formed the foundation of your mind. They remain woven into your identity, even if you can no longer find the path back to them.